Okay, gang, I have to just redo this beginning part here because it got very noisy. Alright, so what I was just saying before, and maybe let me just rewrite the problem here, is that when you are multiplying with fractions, you can reduce vertically or diagonally. So I could reduce this numerator with this denominator and this numerator with this denominator. Okay, and then when I multiply, I go across. 1 times 5 is 5. 3 times 9 is 27. So when we start doing these other problems, you're going to notice that I'm going to reduce either vertically or diagonally. Okay, that's all okay over multiplication. Never okay over addition or subtraction. So let's start to get into the type of problems you're going to do. Here's a good example. We're going to multiply these fractions. So the first thing you're going to do here is you're going to factor. So it's got to multiply to 12, add to 7. Nothing to do on the bottom. And nothing to do over here. If it's easier for you to keep these binomials in parentheses, you can go ahead and do that. For some students, they like to see it like that. Alright, so now, just like I did before, you can reduce up, down, or diagonal. So I could reduce this with this, and I could reduce this with this. Okay, so you can go up, down, or diagonal. So the final answer to this is 4. Alright, let's try this one. This one has a lot of stuff going on, so you may find you're going to sort of do some of your work on the side. So let me start with this piece here. So 36 minus w squared, I'm going to switch the order. I'm going to factor out the negative 1. I'm going to factor the difference of perfect squares. Okay, so that's the first one done. So it's negative w plus 6, w minus 6. Okay, that's the first one factored. Now, it's not that you can't factor it like it is. If it had just been its own individual problem, you wouldn't have to like change the order. It's just that this is a subset of a bigger problem, so you have to have everything in the same order. All right, I'm going to grab this one now. I'm going to do the work below. This is 4 terms, so I have to do factor by grouping. So I'm going to take out a t. Here I'm going to take out a negative 1. Now I'm going to take out the w plus 6. Left with t minus 1. Okay, so this left fraction, I'm totally done factoring it. I'm good with it. Alright, this guy up here just has a common factor of 8. This guy down here, you might want to make the table. It just depends how comfortable. If you guess that, that's fine. It just depends how comfortable you are. Most people make the table, so I'll just do it for you. Give you some good customer service here. Alright, so 2 times negative 6 is negative 12, so it has to multiply to a negative 12. It has to add to a negative 11. Alright, so since it has to multiply to a negative, the signs have to be opposite. But it has to add to a negative 11, means the higher number is the one with the negative on it. Alright, so it's going to be this. So I'm going to break the middle term with that. Right, so now the middle term I broke into this. Now I'm going to do factor by grouping on it. Oh, 6 here. Now I'm going to factor out the common binomial. And I'm left with w minus 6. Okay, I'm going to put that up here. So 2w plus 1, w minus 6. Okay, so these problems have a ton of factoring in them, an enormous amount. All right, now we're ready to reduce. So this was like sort of all my factoring work down here. I'm just sort of organizing it for myself. Okay, Now I'm ready to reduce any numerator with any denominator, up, down, or diagonal. So here we go. This goes with this. This goes with this. This goes with this. All right, so the things that are left are the negative, don't forget that, this 8 and this. That's what's left. So let me see if I can squeeze the final, well, I probably can't. Oh, maybe I could squeeze it up here. All right, let me squeeze the final answer up here. So it's negative 8 over 2w plus 1. You could put the bottom in parentheses or not. It just depends how you like to see it. Okay, and then that's the final answer. So most of the work just comes from doing all that factoring. All right, let me see what else I wrote down here. Okay, let's do this one, and then I'll end this video on this one, and I'll pick up in another video. Okay, again, so there's a lot of factoring to do here. I'm going to start with this one. I'm going to take out a 5. For here, this is a difference of perfect squares. Okay, now let's do this one. Now this one has a common factor 2. I'm just going to take a minute to look at it once I pull this out to see if it's factorable. What am I pulling out of 2? Okay, this will not factor anymore. There's nothing that multiplies to a 9 that adds to a 3, right? Because 9 is only 3 times 3 and 9 times 1, and neither of them given a double negative would make that. So this one is prime. Okay, this one is prime. I hope you see. Let me just do that a little more detail because I'm worried maybe you need to see that a little better. This right here is prime. And again, the reason it's prime is that this is impossible to make. You'd need a double negative. So this double negative adds to negative 10. This double negative adds to negative 6. Neither of them add to negative 3. That's an impossible combination to make for this one. Okay, so it's going to stay like that. Now this over here, this is factoring a cube. So let me just remind you how to do it. So if you have a cubed plus b cubed, that factors into a plus b, a squared minus ab plus b squared. So you're going to take t cubed plus 27. Now remember, it doesn't take the original numbers. It takes what the numbers were before you cubed it. Before you cubed it. So 27 was made from 3 being cubed. So t is my a and 3 is my b. So let's put it in the formula. So it says a plus b. First plus second. First plus second. First squared. The product of the two. T times 3 is 3t. The last one squared. Okay, so now that I've everything factored, I can go ahead and reduce. I don't know how much I stressed this before, so let me just stress it now. The trinomial part of the cube never factors farther. The trinomial part of the cube never factors farther. You never have to, like, some people will try to do it, it's fine. You'll see that it's always prime. I was just going to save you the effort of having to check that. All right, so let's see what we got. I see this goes with this. This goes with this. And that looks like that's it. So we're left with this guy, this guy, this guy, and this guy. So 2 over t minus 3 over 5 times t minus 1. Now once you're done, don't distribute this back in. You actually want it to stay in factored form. We solve things in factored form, not in the distributed form. So this is a better form than a distributed form. Okay, gang, I'm going to pick up the, I'm going to do another video on 8.1 on division, but let me end this one here. Catch you. Bye-bye.